This is the coding challenge, triplets with smaller sum. So it's quite similar to other three sum coding challenges where you're given an unsorted array and you want to sort it. And then given those, given that array, you're looking for triplets or subarrays of three elements that meet a certain condition. And in this case, we're looking for triplets that sum less than a target number. So for example, given this array here and a target of 3, our output would be 2, or 2 total triplets where the elements sum less than 3, those two right here. So let's just get into the plan to solve this. There is a brute force solution to this in Go and in Python, which will be included in the description. But going through the O of n squared solution using the two-pointer technique, which is what we want to use. So first, we want to sort our array since it's unsorted. We set our count of our total triplets that meet our condition or our answer at 0. And then we're iterating through our array with I. And this is our sort of first pointer. So we have like 3 pointers if you want to think of it like that. And our first pointer, I, we're going to iterate up until the third to last element of the array because we want to save the last 2 elements for our other pointers. And as we're iterating through, we want to check for duplicates. So as long as I is greater than 0, we can check the previous element. And then if the previous element and the current one of I are the same, then we just want to continue and skip that duplicate. So the other thing is at each iteration of I, we're going to be using the two-pointer technique on the subarray or the rest of the elements in the array past I. So we instantiate our left and right side pointer. So our left side is always going to be 1 after I, and then the right side is always going to be the last element of the array. At least that's where they'll start. So we want to do our two-pointer technique while the left side pointer is less than the right side pointer. And if not, we just break out of that and update I or increment I. And at each iteration of this two-pointer technique, we're essentially going to grab our sum. So the elements at I, left pointer and right pointer. And if our sum is greater than the target, then we just want to decrement our right side pointer because we know that since our array is sorted, if we decrement our right side, our sum is going to decrease, and we just want to decrease until our sum is less than our target. And if it is less than our target, we are going to update our answer or our count of total triplets that have met our condition. And we're not just adding 1 to it here like in the brute force solution. We're going to add the difference between the right and left side pointer. Why? Because we know that all of those elements are actually going to be less than the sum to less than the target because our array is sorted. So once we do that, then we can increment our left side. And so let's just check that out with the debugger, how that's actually working. So we'll set a breakpoint here as we iterate or increment I. Going to go over to our tests here, debug the test, and we're going to skip the first example and we're going to go to the second one. So bingo, given this array here, see it's unsorted, and now it has been sorted because we've already done that, and this is where we set our breakpoint. So as we step through here, we check for duplicates, not the case, instantiate our left and right side pointer, and now we begin our two-pointer technique. So since the left side is less than our right side, we don't need to stop. We get our sum, and since it is less than our target, as you will see here, so we have I is 0, our left side pointer is 1, and our right side pointer is 4. So all of these numbers in between here, so like if we got every combination within here, any of those sums are going to be less than our target because our array is sorted. So we can basically just add the difference to our answer, which you'll see as I step through here. So we update our answer, and now our answer has 3 subarrays of 3 elements that have met our condition. And we continue. We've incremented our left side pointer, grab a new sum. We can see that it no longer meets the condition, so we decrement our right side pointer to try to decrease the sum here. We grab our new sum, and since we see that it's less than our target, we can increment our answer or count. And we continue through here, and we will find no more subarrays that meet our condition. And so, yeah, that's it. Once again, the code will be in the description. Let me know if you have questions. Thanks.